When you take the square root of a number, you're really just trying to figure out what number times itself will equal the value in the radicand. So, for example, the square root of 4 is 2 because 2 times 2 equals 4. And these, remember, are inverse operations because then if you, again, take the square root of 4 and back down to 2. Now, keep in mind when you multiply a positive number times a positive number, you'll get a positive number, but also if you multiply a negative number times a negative number, you still get a negative number. That's why, from what we know so far, you cannot take the square root of a negative number. Negative 4, there's no two real numbers when multiplied together that would equal negative 4. When multiplied by themselves, that is. For example, if I were to do negative 2 times negative 2, that's positive 4. 2 times 2 is still positive 4. So I can't really do it like that. I can't take a square root of negative 4. At least not using the set of real numbers that we have learned about so far. However, there is something called an imaginary number. And these are used practically in the real world in much more complex mathematical situations, and especially in engineering. But for now, we're just going to learn a simple understanding of what an imaginary number is and how it's used. So the imaginary number I is equal to the square root of negative 1. That's all you need to know about it. And so when you're doing something like taking the square root of negative 4, you can rewrite this as the square root of negative 1 times the square root of 4. And the square root of negative 1 is equal to I, as we identified up there. So this turns into I times the square root of 4, and the square root of 4 is 2. So the square root of negative 4 ends up being 2 times I, our imaginary number. So we have real numbers, which you're familiar with. They're the regular old numbers that we've been working with so far. We have imaginary numbers, which is when you have I, which is the square root of negative 1, or I times any real number. And then we have a third type of number called a complex number. Right now, all you need to know about a complex number is it involves a real number being added or subtracted to an imaginary number. So something like 4 plus I is a complex number, or 2 minus 3I is a complex number. So let's practice a few of these. For each of these values, determine if the answer will be a real number, an imaginary number, or a complex number. And we'll just use real, imaginary, or complex to denote which one each of them will be. The square root of negative 64. Remember, the real subset of numbers cannot have a square root of a negative number, so we have to use an imaginary number to denote that. That would end up being 8I, which is an imaginary number. The square root of 64, that's a positive number. That can have a real number value to it, so that's going to be a real number. 8 is a real number. 10I, even though 10 is a real number, I is the imaginary value, so that is an imaginary number. The square root of 97, that's not a clear, nice, neat square root, but it is still within the subset of real numbers. There's no imaginary number or negative square roots involved. 328I, we have an imaginary number involved in here. 8 plus 3I, this is an example of our complex numbers. We have a real number being added to an imaginary number, so this is a complex number. 7 minus 5, those are just two real numbers that are being added or subtracted, so that answer is going to be real. And then 12 minus the square root of negative 4. The square root of negative 4 is going to be an imaginary number, and 12 is a real number. So when we have a real minus or plus an imaginary number, we call that a complex number.